Take a look at the world around you. The chair you're sitting on, the book you're holding, and even the air you're breathing are all made of matter. But how do we tell one type of matter from another? We do it by looking at their properties. Think of properties as a substance's personality traits. They're the unique characteristics that define what it is and how it behaves. So what are properties exactly? They're the characteristics we can use to describe matter. If you were describing a friend, you might talk about their hair color or height. Similarly, when we describe a substance, we talk about its properties. These can be physical, like its color or how much it weighs, or chemical, like whether it can catch on fire. Let's start with physical properties. These are the characteristics you can observe or measure without changing the substance itself. Imagine you have a wooden pencil. You can see its color, feel its hardness, and measure its length without turning it into something else. All those are physical properties. They help us describe what a substance looks like and feels like. Two of the most important physical properties are mass and volume. Mass is simply how much stuff is in an object. If you were on a spaceship, your mass would be the same, but your weight would be different because there's less gravity. Volume, on the other hand, is how much space something takes up. Think of a big beach ball. It has a large volume, even if it doesn't weigh very much. We measure mass with a scale and volume with a measuring cup or cylinder. Now let's talk about density. This is a cool property because it tells us how tightly packed the matter is in an object. Imagine two boxes, both the same size. One is filled with feathers, and the other with rocks. The box of rocks has a much higher density. Density is calculated by dividing an object's mass by its volume. This is why a small stone sinks in water, while a huge log floats. Another key physical property is solubility. This describes whether a substance can dissolve in a liquid. Think about adding sugar to your tea. You stir it, and the sugar disappears, right? The sugar has dissolved, so we say it's soluble in water. But if you try to dissolve sand in water, it just settles at the bottom. That's because sand is not soluble. Have you ever seen water turn to ice or steam coming from a boiling pot? These changes happen at specific temperatures, which are also physical properties. The melting point is the temperature at which a substance changes from a solid to a liquid. For water, that's 0 degrees. The boiling point is when it turns from a liquid to a gas. For water, that's 100 degrees. Every substance has its own unique melting and boiling points. Magnetism is a fascinating property. Some substances, like iron, are attracted to magnets, while others, like plastic and wood, are not. This property is very useful. For example, if you have a pile of nuts and bolts mixed with small plastic pieces, you can easily separate them using a magnet. This shows how knowing a substance's properties can help us in real life. Now for a different kind of property, chemical properties. These describe a substance's ability to change into a new substance. You can't observe a chemical property just by looking at something. You have to see how it reacts with other things. For example, a piece of paper looks like paper, but you only see its flammability, a chemical property, when it bursts into flames and turns into ash. A great example of a chemical property is flammability. This is the ability of something to catch on fire. We know that a dry log can burn, but a glass window can't. That's because wood is flammable and glass is not. When wood burns, it changes into a new substance, ash, and releases smoke and heat. This is a chemical change, so flammability is a chemical property. Another chemical property is reactivity. This tells us how easily a substance reacts with others. A classic example is a science fair volcano. When you mix baking soda and vinegar, they react with each other to create a bubbly eruption. The bubbles you see are actually a new substance, carbon dioxide gas. This reaction proves that baking soda and vinegar are reactive with each other. So why do we care about all these properties? Because they're the clues we use to identify substances. Scientists often collect data on different properties and organize them in tables or charts. By analyzing this data, we can figure out what an unknown substance is or how to use it. It's like being a detective and using a substance's properties as evidence. A data table is a great way to organize information about properties. You can have columns for different substances like water or iron, and rows for their properties like color, state of matter, and density. This makes it easy to compare and see the differences between substances at a glance. Let's pretend we have a mystery substance. We don't know what it is. To figure it out, we can perform some simple tests. We can measure its mass and volume, see if it's magnetic, and maybe even test its boiling point. Once we have all that information, we can compare our data to a list of known substances. If the properties match up, we can confidently say what our mystery substance is. Let's try a real example. Imagine we find a shiny, mysterious piece of metal. It's our job to identify it. First, we'll measure its mass with a balance and find it's 54 grams. Then, we can find its volume by submerging it in water and see that it displaces 20 cubic centimeters of water. Now that we have the mass and volume, we can calculate the metal's density. Remember, density is mass divided by volume. So 54 grams divided by 20 cubic centimeters equals 2.7 grams per cubic centimeter. Next, we check a data table of common metals. We see that aluminum has a density of 2.7 grams per cubic centimeter. That's a perfect match. Based on our data, we can draw a strong conclusion. Our mystery metal has the same density as aluminum, so it's very likely that our metal is indeed aluminum. This shows us how a single property, like density, can be a powerful tool for identifying a substance. This is what scientists do every day. Let's look at another example of how we use properties to separate a mixture. Say you accidentally spill a container of salt and pepper. How would you separate them? Well, salt is soluble in water, but pepper is not. So you could add water, dissolve the salt, and then filter out the pepper. This method uses the property of solubility to separate a mixture. While one property can be very helpful, it's always best to use more than one. For example, both water and rubbing alcohol are clear, colorless liquids. Just looking at them, you can't tell the difference. But if you were to measure their boiling points, you would find that water boils at 100 degrees Celsius and rubbing alcohol boils at about 82 degrees Celsius. So by analyzing a different property, you can easily tell them apart. So to wrap things up, analyzing data on the properties of substances is a fundamental part of science. Whether we're identifying a mystery metal, separating a mixture, or just understanding why certain things behave the way they do, we rely on properties like color, density, melting point, and flammability. This skill helps us make sense of the vast and varied world of matter.